I'm going to have you do this. I want you to translate the top and the bottom one. So translate both into algebra. And then I want you to find one reason how they're alike and how they're different. You can work together. You can do it by yourself. You can talk to each other. How did you translate this? See if yours is the same as someone else's. Talk about your alikes and differences. Did you get the same one? Did you get a different one? Oh, I didn't think about that. Stuff like that. You can use markers. You can use pencils. Wherever you want to write that down at. I'll give you a couple minutes to do all those levels. All right. I need one person, so raise your hand, to give me how they translated twice the quantity of a number less than 5 increased by 8. No one says on that one. What about the second one? How did we translate that one?
8, parentheses, x plus 8, parentheses, to the power of 2 minus 5.
So the sum of, we're adding two things. We're adding two things. A number, Kate called it x, and 8, all squared, so outside of parentheses, less 5. So this is how we should have translated the second one. Someone give me a first, I guess, for the first one. Sorry.
2x minus 5 plus 8.
2x minus 5 plus 8. So I'm going to fix this a little bit. You are on the right track. Twice the quantity means we're going to multiply 2 times everything it says. So we just need to set a parentheses. Right? So 2 and then parentheses x minus 5 plus 8. All right? And then tell me one thing you saw that they had alike or was similar.
All the numbers.
Okay.
They both had 5 and 8.
Okay. And 5 and 8 and 2, even though they're in different places. Okay, good to go. They both have parentheses. Jackson, is that what you were going to say?
Yeah.
Yes. Okay, sorry.
Both have addition and subtraction.
Both have addition and subtraction.
No, they both have multiplication.
Yes, in different ways, but they are both multiplying. So that can really be a like and a difference. Say that one more time. Okay, so I'm gonna change it just a little bit. Are they both being squared? No. No. So that would be a difference. But they are both have the 2, and we said that part. Sorry. Okay, they both have a variable. In this case, we chose the same variable. Anything else? Any other similarities? Sorry.
X in parentheses.
Okay, so I can specify that. X is in the parentheses. They both have X and it's in the parentheses. We could have chosen different variables. It wouldn't matter. They both have an X and a 5, but that's what we're really. So they both have a negative 5 and a positive 8. Okay, so even though they have the same numbers and they're both adding and subtracting, they're both adding 8 and subtracting 5. Any other similarities that we saw? Okay. What about differences? How were they different?
They do multiplication at different times.
Okay. So I'm going to specify that. One is being multiplied by 2. The other is multiplying to itself. So you don't have to write these down if you wanted to. You can. Okay, so even though they're both adding and subtracting the same thing, one gets subtracted versus added and then vice versa. So I'll put that they add and subtract, the order is different. Anyone else? Okay. It comes back. Let me know. I want to say those were all some similarities that the other classes came up with. Did it come back to you? Another difference that some other class said, the wording is a little different. So less than 5 and less 5, they're both using the words less and 5, but how they put it is different.
They probably have like different sums.
Like
They equal it
Yeah.
to different things.
okay, they probably do, yes. If we worked them out, they would give us different answers, results.
What has one being multiplied by 2 and the other one half?
So that one kind of goes into this. This one's being multiplied by 2. Well, this one's not being multiplied by 2, it's being multiplied by itself. Right? Anything else? Go ahead. Okay, so that kind of goes with this one, the numbers, but more specific, what's in the parentheses is different. Right, that's a good list. So this was just a quick warm-up to get us back into what did we do last time, as well as think about the math in different ways. Right. I don't need to show this. Cool. So I will. If you ever want to, so I need everyone's attention up here. I know who wants to play with algebra tiles. Give me 2 seconds. If you ever want to play with the virtual algebra tiles on your own time, in Canvas, there's a side link, electronic algebra tiles. It'll take you to the same link I'm going to. So you have that access whenever. Okay. So we are going to model some expressions using algebra tiles. You may have used them before, you may have not, so we're going to just go over really quickly what each type is. Maybe if I can take them.
This is square.
Alright, so everyone find the smallest square. Those are your ones. Some of you have yellow, some of you have beige. The yellow beige side is your positive one. And then on the back is your negative. Red is always negative. Then find your rectangles. They are green and red. The green side, they're X's. Green side is your positive X. Red side is your negative X. And then find your big squares. Those are your X squares. Blue side is positive X squared. Red side is negative X squared. Right? So I'm going to be doing this up here while you guys are doing it on your desk, doing the algebra tiles. So we need to model 3x. I have to do this from my computer because it doesn't like the smartboard. I don't know. So we have to figure out how would we model 3x. Which tiles would we use? The rectangles, the x's, and the positives or the negatives? Positives. Now, if you are using this website, if you choose this times 3 over here and put whatever, it will multiply it by 3, so you don't have to bring down 3 different ones. So 3 green x's, so you should have that modeled on your desk. 3 green x's to show 3x. Right? And that would be 3x. So going on to the next one. What about 6? How would I model 6? Squares, which ones? The positive, which squares? Smaller ones, the positive ones. So you need 6 of those. Get those out. So if you had 6 ones, that would model a 6. So Max, you can draw them out, but you also have the tiles too. Right. We just did this one, so I'm going to skip that one. 5x squared. How would we model that one? So I heard the rectangles, and then I heard the big squares. So if we do the big squares, that is what we want. The rectangles would not give us the x squared. So make sure you're looking for, does it have x squared or does it not? Faith, do you want to come here for a second? You want to come up here? You too. So not that bell in 5 minutes. 3x squared. 3 of the big squares, yes. Right? -4, how would we model that? 4 tiny squares, but on the negative side, so they need to be red. Alright, now it's taking a step further. Now it's doing 2 things. So someone tell me just one of these things. How would we model either the -4x squared or the 4x? Doesn't go. Okay, so we would have 4 of the bigoted, I mixed those 2 words up. Try again. The big x squares on the negative side. If I could speak today, that'd be great. Alright, and then the positive 4x. The rectangles.
4 rectangles.
4 green positive rectangles. Good. So if you have 4 red big squares and 4 green rectangles, you got that right. Alright, let's try again. 3x squared minus 3x. Someone give me just one of those things. Ella? How many? 3. Okay. And then -3x. The red rectangles. 3 of those. Alright. So if you have that, yours matches. You got that correct. I'm going to skip this one so we can go on to... So now we have 3 things going on. Someone give me one of those things. How would we model just one? Sorry.
5 big squares.
5 of the big squares on the positive side. Bless you. Someone give me another one. Jezebel. 2 rectangles on the negative side, and then the -1. Oh, Clarissa. One of the small negatives on the red side. Right. We have time to maybe do one more. -x squared plus 4x plus 3. So you guys go ahead and model that. -x squared plus 4x plus 3.
Honestly. So you would. I'll do that.
Are these x's or these x squares? So I'm going to put these up really quickly for a second.
What?
Oh,
Are you actually? You don't know? Okay, but you can't tell by the sizes of what you're
So we should have had 1 negative x squared, 4 green positive rectangles, and 3 positive ones. You can leave your tiles on your desk for when the bell rings.
Wait, can we go back wrong?
Yes, you can. Okay, so 0 pairs are, you have to think about that like additive inverse. If you have a positive and a negative, if you combine them, you get 0. Same thing here. You want to create 0 pairs so that you have a positive and a negative version of whatever, so that they cancel each other out to become 0. So now we have 5 positive x's. We want to get to 3. So we have to add in negative x's so that they cancel until we get to 3. How many negatives would we put or add in? 2. So what you would do is put the 5 up here, and then you would put 2 negatives up, and then you would put the 2 negatives next to 2 of the positives. In my case, when I put them next to them or on top of them, they're going to disappear. But when you put them next to that, that would say that's a 0 pair, they disappear, and you can put that off to the side. Okay, let's do another one. So now we have 6. We want to get 4. Excuse me, how many 0 pairs are we going to make to get 4? We're going to put in 2 negatives, yes. So again, you would put out 6 positives, put 2 negatives, and then the 0 pairs kind of move those off to the side. They have disappeared, they are trash, not actually, but in this case, that's what they would be. Let's try it again. Okay, I'm going to skip this one because I want to do an x squared one.
So.
Let's skip this one. Okay, we're not going to do the entire thing, but if I have 2 and I need 1, how many 0 pairs are we going to create to get negative x squared? I heard 1. So I'm going to add in a positive so that it is now just 1 negative. So I'm not going to do the rest of that, but we could add in 0 pairs if it had given us also some. So now we're going to use our algebra tiles to actually model some of their expressions. So we're going to start with this first one. So you're going to model as I model, / before, whenever. We're going to ignore these, not count those in whatever we count, because those are the ones I'm going to be pulling from. Okay. So how would we model x? These are the same, by the way. These are your x's, positive, negative. These are your 1s, positive, negative. I don't have x squared up there. So how would we model x? Just one of the green rectangles, a positive green rectangle. Plus 1, how would we model that? One of the smaller ones on the positive side, and then negative 2x. No, 2, not that one. Take 2 of the red rectangles. 2 of the red rectangles. So once you have it modeled, then you're going to look for 0 pairs. Do you have a positive and negative version of whatever? It could be x's, it could be 1s, it could be x squared. Do we have something that has a positive and a negative? Yes, our x's. So you would take that positive and that negative and kind of move it off to the side. That's going to be your trash pile. It disappeared, it became 0, then canceled. And then you would just see what's left. What's left? Is this positive or negative? Negative. So negative 1x plus 1, or we could just write negative x plus 1. Make sure you have that written down on your actual notes. On these ones? Questions on how we modeled that, how we found our 0 pairs to simplify, and how we got our last our final answer.
Wait, what was the question?
Do you have any questions on any of that process? Alright, let's do not the next one, but the one after that. This one. How would we model negative 2x? Two of the negative rectangles were the x bars and the red. And then positive 3x. How would we model that?
3 green
rectangles. Negative 2.
2 squares.
Red. Negative, yes. So we say red or positive, negative or positive, yes. And then negative 1.
Another red
One
square.
red square. Right. Do we have 0 pairs?
Yeah.
Yes. How many?
2.
2. So we can get rid of both of the negative x's and 2 of the positive x's. Oh, I got one, but I'm adding words. Okay. And then we can rewrite or remove
1x minus 3.
1x minus 3. Questions on how we modeled that, how we got rid of the 0 terms, how we got our final answer. Make sure you have that answer written down. We're going to skip the next one and do the very last one. So I want you to go ahead and model those. I kind of spread mine out because there wasn't enough space. Yours should look like this when you model 2 positive 3s, 3 positive 1s, 3 negative x squared, 2 negative 1s, 1 positive x squared, and 1 negative x. Then you're going to find all of your 0 pairs, your 1 0 pairs, your x's 0 pairs, and your x squared, and you're going to put those together and move them off to the side, make that your trash pile, and see what's left. So I'll give you a second to do that. Did everyone get this as a final answer? You will not get that as a final answer. What is left?
1x plus 1 minus 2x squared.
Right. So I took what you said but rewrote it. We have to write these a specific way. Highest exponent will always go first, and then things without an exponent but a variable, and then things without a variable just a number by itself. So it always has to be in that order.
Oh man, chill out there.
Questions on how we modeled that, got that answer, got rid of the 0 pairs? So now we're going to go on to the next page, and I'm going to show you how to do this algebraically. And then if you still want to use the algebra tiles after that, you're more than welcome to. But if you like the algebraic method instead, then you can keep using it. Alright. So when you're doing this algebraically, you want to kind of do what we did last week. Sort terms that look similar together. Group like terms, but you also want to combine like terms. So we're going to find things that have a variable and the same variable. And you want to include whatever symbols in front of that, that way we know what operations we're using. And then anything that does not have a variable is going to be grouped together. So we have two sets of like terms. And then to combine them, we're just going to take the numbers in front, so -2 and +3, and add those together. We'll come back to the x in a minute. So let's see. +1. And then you just put x afterwards. So add the numbers together and then put x afterwards. We're not like combining the x's and putting multiple x's. Okay. Then do the same thing with your numbers. -2 minus 1 would give us -3. Then you take these two and just rewrite them. That answer should look familiar. It's the same one we just got on the previous page. We've just now done this algebraically. Do you have any questions on how we found the like pairs, combine them to get the final answer? Let's do the next one. Same process. Find your like terms. You have more x's in this one. So, and you don't have to use boxes. You can circle just different shapes or colors for every set of like terms. -2x and -x. And then we have -4 and +2. And then again, we're going to do the same thing. Remember that there are invisible ones in front of these x's. And we're going to take these numbers, 1, -2, -1, and figure out what that would be. You can do that all at the same time. You can do 1 -2, and then -1. You can do -2 -1, and then go back and do 1 minus at the beginning. What would that be? Double check that. Should be -2. So you weren't too far, but it just wasn't right. Just double check. So -2x. And then -4 + 2.
What?
-2.
There.
And then -2x minus 2. Sorry. So that is our final answer. -2x minus 2. We don't do anything else with that. We can't combine them. They're not like terms. Questions on any of this process? Did we get lost at any of that process? Try the last one. So now you have x squared. Remember that from last week when we had exponents, we don't group those together with the variables. Exponents are its own thing. You have an answer?
I was sure you said
Yeah, so we're just going to do the same thing we did with the x's, so with this, but it will just be -3 plus 1 squared. This isn't your class.
Oh.
So mine's physics.
But if you ever want to know, it's hard to see. But your quiz dates are on this board over here. It'll also be up here, but this isn't your class. Take the landing. You know where the closest bathroom is.
Honestly, guys, I feel like I'm pretty ready for quiz anyways.
Oh, look. Stop.
Alright, someone tell me what the final answer was.
X plus 1 minus 2x squared.
Close. We just have to change that order. Highest exponent always goes first, then variables, then.
What'd you get 4?
So make sure that when you're doing this, the x's will go together. So that would be 2 minus 1. The constants will go together. So that would be 3 minus 2. And then these will go together. But you are not squaring these. You are only taking the number in front and combining those. So negative 3 plus 1. And that is. Alright, questions on this one?
So if it has an exponent, it's its own.
Yes, this is only negative. Alright, go on to the next page. Alright, and then find any questions that look complex, look complicated, you're not really sure where to start. You want to just do together any of those. And I will say if you choose 5 and 7, we're only doing one of those. So choose one. Oh, you have one. Which one?
Wait,
We're going to do 7, that means you are going to eventually do 5. Any others on this page? 6. Yes. Any others? Okay, so we're going to do 6 and 7 so far. Alright, so let's start with 6. And in general, you can use that algebra tiles on any problems except ones with decimals, ones with fractions, and ones with multiple variables. So if you see any of those and you want to use the algebra tiles, you have to do it algebraically. There is an algebra tile set that has 2 different variables, but I don't have that, so we're just going to use that. Alright, for number 6. The process here is the same as what we were just doing. It just looks more complex because it's decimals and fractions. So we're still going to look for our like terms, which are what?
0.25k, negative k, and then the constants are 1.5, and then negative 3.5.
So those are our like terms, and we're going to combine them just like we did before. So 0.25 minus 1, negative 0.75k. And then we're going to subtract 1.5 minus 3.5. And that'll be negative. And then you just rewrite those as your final answer. Questions on that one? So no. Once you get the hang of combining the terms, this process here, you'll not need to. As long as you have that correct answer. Now, for your fractions, yes. So, okay. Other questions on that one?
Okay.
Alright, so we're going to do 7. And we want to show our work with our fractions, because we may have to change them, and then I'll show you how to double check in your calculator. Right? What are our like terms here? So it's one set, and then the others will be your numbers up here. If these were nice fractions, so like 1 divided by 3 is not a nice fraction, it's going to give you a repeating decimal. If it was a nice fraction, nice decimal, then you could change them to decimals, but in this case, because of that, we're not. It doesn't really matter which one we do first. Let's say I do the 11/12 first. In order to combine fractions, we have to have the same denominator. So we have to change this 3 to 12 by multiplying it by. And then what we do to one piece of the fraction, we also have to do it to the next piece. So this would become 11 over 12 minus 4 over 12. And then you're just subtracting your numerators, keeping your denominators the same. So what was 7 over 12? Right, and then we're going to do the same thing for -1/6 and 5/6. Now, in this case, the denominator is already the same, so we just have to add our numerator to get 4 over 6. But in this case, if you can simplify or reduce, always do that. So these can both be divided by 2, so that would become 2/3. So an example like this, I would want to see that you worked out your fractions and then got the final answer, but the example like the last one, you don't necessarily need to show those two things. So it depends on the problem. The showing the work part. So, yes. Alright, so now I'm going to show you in your calculator. So if you don't have your calculator, go grab that. And do all of the things. So the very first thing you're going to do, I'm going to do this. Okay. We are going to reset our calculators because everyone uses these calculators all day, so we don't want someone else's math interrupting our math. We're going to go into second, the blue button, and then hit plus, and then the number 7, 1, 2. So whatever I do is going to pop up down here. So if you ever forget what I did, you can look down here and look at my key history. Second, the blue button, plus 7, 1, 2. Yes, RAM cleared it. Cleared the entire, reset the entire calculator. Right? Then I'm going to show you how to put fractions into the calculator. You're going to go into alpha, the green button, and then hit y equals at the top. And you're going to get a menu that looks like this. So in that menu, you want this first one. You can either hit 1 or hit enter, either or, doesn't matter. And you should get a fraction bar.
What did you do?
Anyone not get a fraction bar? Anyone else not get a fraction bar? Did we get it? So from here, you can always go second mode. And then try again. Alpha. Y equals.
Okay, I got this.
Okay, great. Alright, and then we are going to put in the same fractions from before. So let's do the 11/12 minus 1/3. So in the top, you're going to type in 11. You're going to hit the down arrow to come down.
This is so amazing.
And then you're going to hit the right button to come out of the fraction. Because if you don't do that, you're going to start typing numbers in the bottom that you don't want. Second mode. And then alpha one. Right. If you get to a screen that's not this, and you want to go back to this screen, second mode. That's your go home. Right. So then we were subtracting, so minus 1/3. So then alpha y equals again. 1 or enter. Put 1 in, go down, put 3 in, hit enter. Anyone not get 7/12? We're going to do this one more time with the other example. Did you get it, Grace, or did you need help? How'd you do that?
By listening to what the teacher was saying.
No, because she didn't say it fast enough.
She didn't say it fast enough, so she said it too fast. Because at this point, I think she said it pretty darn slow.
No, because
Let's try one more so we get more practice. Let's do this one. Negative 1/6. So again, alpha y equals 1 or enter. Now, you need a negative. So you want this button by enter, not your minus.
Wait, do we hit enter to get that answer?
1 or enter, either or, doesn't matter. So negative, not minus, so negative by enter, then 1/6. Second mode. Negative 1/6 plus 5/6. Alpha y equals 1 or enter. 5/6.
This is so.
And then hit enter. You should get 2/3. It will simplify it for you. Uh-oh. Anyone not get 2/3? Did you get 2/3?
I got
How do we get there?
syntax.
Alpha y equals. I got error. So that means you put in a minus instead of a negative. Same thing. So it's highlighting right now. Hit this, not this, and then hit enter.
I see.
The negative is at the bottom. Don't hit minus.
Yes, I did. How much of that did I do for you?
No, I'm talking about this one. I'm talking about this one. I did
the whole thing.
I did this one on my own. But I did this one on my own. I just got my own, so it's fine.
Oh, alright, here we go.
It's
Did you make him get it?
I was gonna say, I have this.
Zari, did you get yours fixed?
Yes.
Cindy, did you get yours fixed? Anyone else still need theirs fixed? Okay. So we're going to be using. Did you need help with
Oh,
something?
no, I got it. Okay.
We're going to be using this a lot, so you'll need to know how to find fractions. I'll help you a few times, and then otherwise, I'm going to ask you to ask yours. Okay. Other questions on this page that you need or want help on? / how to start before I let you practice one on you.
Not yet.
Yes. Keyword.
She means when I get home, not yet.
Correct.
Come on, guys.
The power of yes.
I think you dropped
Okay, number 4. What are our like terms?
-6a, -5a,
Negative.
and then
plus b is its own thing.
Correct.
And then negative 1 is also its own thing.
Also correct. So I'm not even going to group those because I don't need to. I could, but there's different. So if we combine these two, negative 6a minus 5a is how many a's?
Negative 11.
11a.
Backward.
And then because these didn't get combined with anything, you just drop them down. These will always be A and C order.
Oh,
5. So 5 is going to be one you guys do on your own, but I can help you. Okay. Alright, I want you guys to try number 5. I'll give you a couple minutes to do that. And then we'll come back and we'll talk about it.
Okay. I have my calculator. The one that you could barely use.
okay, so I'm going
Can I do my work?
Alright, who wants to give me their answer?
I want to do it.
Okay, go ahead.
I got 1/6p minus 4/5. Thanks,
Who
man.
else got that answer?
Who else got the answer?
Good.
Good.
Alright, does anyone need me to do that math up here on a just in case you did not get that answer? So we can figure out where we went wrong or anything like that. That was the correct answer. Good job. Go on to the next page. We're just going to do a couple more.
I'm literally gonna die.
Louise, you know where the closest process is.
Very.
So, on this page, but not this one, the next one. So, I'm going to show you how to do this algebraically. But first, does anyone want to see how it would be done with algebra tiles? Okay. So, in a moment, if you're done with the algebra tiles, I'll let you put those up. Not right at this second, but in a second. So if you were doing this algebraically, you're taking whatever number is on the outside and you're multiplying to every number on the inside. So the 1 in front, not the x itself. And then once you get the hang of this, you will not need to put this part, but for now, we're going to put this part. So we're multiplying 3 times 1 to get 3. And then putting x afterwards. And then multiplying 3 times 2. And then once you have those two things, you're going to rewrite it. And that would be your answer.
Distributive. What is that?
Distributive property where we use multiplication. There we go. It was a mixture of those two things. There we go. Okay. Questions on how we do that? Do the next one. Same thing, multiply the 2 to all the numbers in front. So the negative 1, not the x itself. So we would get what?
Negative 2.
2, put the x behind it, and then positive 2. So our final answer, negative 2x plus 2. Right. Any questions on how we distribute?
No.
Go on to the next page, and then if you are no longer using your algebra tiles, you can go ahead and put them back in the bag, put them in the container. Okay.
Well, because we don't know if we distribute before or after we.
So, sorry I asked this question, this is exactly what I was about to explain. So in this case, because if you're thinking order of operations, you want to do your parentheses grouping first, you can do it that way. But then I'm also going to show you how you can do it the other way. So, let's combine the terms first. So if you're doing order of operations, you're doing what's on the inside, so combining the terms. So if we combine those, what would we get? Negative 2x plus 5. Right? Then we would go ahead and distribute. So multiply that to everything there. What would that give us? Plus 10. There we go. Okay. Then I'm going to do this again. I'm going to rewrite this whole thing. And now let's say we forgot about our order of operations and we saw parentheses and immediately wanted to distribute. Let's do it. So we're going to distribute to every single thing. So you have negative 2x plus 6, negative 2x plus 4. And then, just like we were doing before, we would have to now combine like and we would get negative 4 times 10. So the answer to Daria's question is it doesn't matter. For this only, for simplifying expressions, it does not matter. When we get into evaluating, order will matter. But right now it does not. So either or. Questions on that? Right, let's do this next one. And then I think we'll do one more and then we'll be done for today. Okay? So go ahead and distribute. What would we get after we distribute? Negative 6. And then 3 times negative 1. Negative 3. We're going to bring down that 4x. So whatever is on the outside, we just bring it down. We cannot combine that with anything until we've brought everything down. Now, we can combine like this. What would that be?
Negative 2x
minus 8. And that would be our final answer. Any questions so far about how we distribute and combine the terms? Alright, next page. It is a lot, but I believe in you guys. We can do it. Alright, so we're going to distribute twice at the same time. What would the first one be? Plus, not 6, but 8. There we go. Make sure you're multiplying, not adding. And then bring down that negative 3x. And then what would the last part be? And then 2 times 3 plus 6. You have a lot of terms, and then you're just going to combine.
So 4x minus 1.
Take a second, do that. What would our final answer be?
Negative 1x plus 4.
We could do the last one, but I'll hold off on that one. We'll do that Thursday. So, couple things. One, I put in your Delta Math scores on translating expressions that we're going to do on Friday. If you have not done that, or you did it after I sent out the I did this email, you need to email me so that I can update your grade. / if you have not joined or did it, I'll be calling you up to make sure you do it. You have another one that's due on Thursday on simplifying expressions. Some of you did it already, some of you started it, but now you should have all the tools to finish it. And you can put your calculators away. Look for pieces on the floor